All right, good morning, everyone, and thank you for joining us this morning for our Crop Hour webinar series. For those of you who don't know or first time here, my name is Shelby Pritchard. I'm currently the IPM specialist here at SDSU, as well as the moderator for this webinar series. Just a quick reminder, after each talk today, we will have a short poll that will pop up. Just a couple of questions, it'll remain anonymous, it just helps us. Also, anyone looking for those CCA credits, we will have those pulled up and we'll leave that up there for you after each talk. And once again, feel free to ask any questions throughout the presentations. So today we'll just jump right in. Our first speaker is Dr. Tong Wang. Dr. Wang is currently an associate professor and advanced production specialist located on the SDSU campus. And today she will be giving a talk titled Farmers' Usage of Cover Crops in South Dakota.
Okay, so let me try to share my screen first. Okay. So can you see my screen now?
I can see the screen, yep.
Okay, let me just make it a slideshow. Okay, so my topic today will be the farmers' usage of cover crops in South Dakota. And I'm an advanced production specialist in the economics department of South Dakota State University. So this presentation will cover the recent crop studies in the eastern South Dakota. We did 2 surveys. So basically, I'm going to introduce, it's kind of, the cover crop adoption rates between 2018 and 2021. And I'm going to introduce the cover crop usage by the usage years, how many years producers have been using cover crops, and then how many percentage of the fields they have used cover crops, and then the cost share the producer received, and then the role of cost share on the cover crop usage, and then is the perceived profit change after the cover crop adoption and the factors affecting the perceived profit. Lastly, I will introduce the benefits and the perceived challenges of the cover crop adoption. So with those objectives, I will first introduce our survey. So you can see from here, basically there is a map of South Dakota, and this border shows the counties surveyed. So basically we choose the counties based on the acres of corn acres, so that we try to just choose more farmers from the counties that have more corn acres. So the acres, the corn acres, you can see that is reflected here, the planted acres. So you can see the darkened colors represent more corn acres in that county. So in that case, we will choose more farmers. So those are the county borders. And this is our survey method. So first we send out an advance letter with a $2 incentive with a link for the online survey. So basically the producers can have a chance to do the online survey. If there's no response for the online survey, we send out the paper survey with a return envelope, and then the postcard reminder, and then a second round of paper survey with another return envelope. So we did 2 surveys. One is in 2018, the other is 2021. So the 2018 one was done in January to March, and so that's the 2021 survey. So the survey sample for 2018 is from 3,000 FSA participants. And then we received 708 samples for the 2018 survey. So it accounts for a response rate of 30%. And then for 2021, we use the same respondents for 2018. So we send out the survey to those respondents, and it ends up get to 350 back. So with a 59% response rate. So with those survey samples, we carried out a series of analysis. So here is some basic facts about the cover crop usage in 2018 and 2021. So we found that in 2018, 51% of people use cover crops. And then in 2021, basically, we look at the same group of farmers who responded to both 2018 and 2021, so that this is comparable. So with this same group of farmers, we can see that the cover crop usage rate have increased slightly from 51% to 57%. So this is a overall adoption rate increase. And then we look at the 2021 survey and look at how many people have used a cover crop for different years. So we found that 43% farmers use a cover crop for less than 3 years, and only 14% use it for more than 10 years. So the rest either use it for 3 to 5 years or 6 to 10 years. So overall, we found that most farmers still use a cover crop for less than 3 years. So which shows that cover crop usage is fairly a new trend in South Dakota. And then we look at, among the farmers who use cover crops on their land, how many, how much land is covered by cover crops. So the first criteria is 1 to 20%. So we can see that more than 60% of people actually use cover crops on less than 20% of their land. And then another 20% use on 21 to 40. But above 40, there is less than 20% people together. So which shows that most farmers use cover crops, but is on mostly is under 20% of their total crop acres. And then we look at the cost share. How many people have received the cost share when they are using cover crops? So we can see that roughly about 65% of producers use cover crops did not receive cover crop share to adopt them. So which means 35% received cost share. So that is like 1/3 of producers receive cost share. So most of them did not receive cost share. So we try to see what's the role of cost share in promoting the cover crop usage, because most people didn't receive cost share. So here we compared if you receive cost share versus you didn't receive cost share, what's the impact of the percentage of acres under the cover crop on your field. So here this yellow bar means no cost share received. Blue bar means cost share received. So we can see that with no cost share received, 65% of people actually use that on 1 to 20% of land. But with cost share received, only 54% of people use on less than 20%. Meanwhile, the other categories have increased, especially the 81 to 100%. So we can see that the cost share actually promoted the percentage of land under cover crops. So this shows the role of cost share. It does promote the acres and the cover crops from this study. And then we take a look at the producers' perceived profit, yield, and cost change after their cover crop adoption. So those are in percentages. So we can see that for the profitability change and the cash crop yield change and the production cost change. So for the two, profitability and yield, so 61% actually perceived very little change after cover crop adoption. And for the cost, 45 perceived very little change, which means within 5% of the total cost change after cover crop adoption. And then we take a look at the people who perceive the increase in their profit. So we can see that for the profit change, about a quarter of farmers perceived either an increase by 5 to 10% or an increase by more than 10%. So very few people actually perceived the profit have increased by more than 10%. But the cost, actually, most people perceived is increase the cost. So we focus on the profitability change. So we took a more look at the profitability change perceived by the farmers of the 2-year survey. So we compared people's perception of the 2 years. So the finding is it's very similar. So you can see that for both years, it's actually more than 61% perceived a more than with about a little change within 5% of change, and then 20% perceived increase by 5 to 10%, and then like 2 or 3% perceived it increase profit by more than 10%. So both years is very similar. So we will look at what has more respondents. That is the 2018 survey. We have more than 700 respondents. So we arrange those by the usage years. So if we look at usage years and then the cover crop profitability change, then we can see a clear trend here. So we use red here to mean that there is a reduced by more than 5%. So we combined two categories, reduced by 5% or reduced by 10%. Those we combine into one category. So that means a profitability have reduced. And then the green bar here, that means the profitability have increased at least by 5%. And this gray bar here means there's very little change. So we also arrange it by never used, less than 3 years, 3 to 5 years, 6 to 10 years, and 10 years and more. So we can see that never used, only 16% they perceive that cover crop will increase their profitability. But for those less than 3 years, this percentage increased to 20%. And for 3 to 5 years, increased to 29%, and then again to 35%, and to 40% to those who have used it for 10 years and more. So this shows a clear trend that when producers use cover crop for a long period of time, a longer period of time, it's kind of increase their perception that cover crop actually increase the profitability on their fields. And meanwhile, we can see that those very little change kind of a little bit decreased, and then they reduced by 5%, have somehow fluctuated by the categories, but overall it has a reduction trend. But the clear trend is we can see that this increase has increased over the years. So this is the profitability relationship with the cover crop usage years. Another factor that affects the profit change is whether the producer has a pasture or no pasture. So has a pasture we associate with livestock grazing. So we assume that producers also graze their cover crops. And no pasture, we assume that cover crop is used without being grazed. So we can say that those who has the pasture or has a potential for use cover crop for grazing purpose perceive a much higher profit change. So here we have a indicator here. This 3 means there's no profit change. So I use a red line here, and then below 3, that means a reduction in profit, and above 3 there means an increase in profit. So we can see that overall, those with the pasture or with cover crop grazing potential, they perceive an increase in the cover crop profit, but those have no pasture or no grazing potential, they haven't perceived an increase in profit change or a reduction in the profit. So this is another factor besides the usage years that has affected the profitability. So another thing we look at is the benefits. Besides the profitability, what's the benefits perceived by the South Dakota producers? So those are the top 3 benefits. We only just present the percentage producers that strongly agree with those benefits. So there are producers who either agree but not strongly agree, so we didn't show the percentage here. So all those percentages are the producer strongly agrees those benefits. So the top benefits is in improved soil health, which is about 25% or a quarter of producers who strongly agree with these benefits. And the second one is increases the water infiltration. So this is 22%. And another one is we mentioned with profitability perception. Those who have the pastures perceive more profitability. So this one, the producers also perceive that a third benefit is cover crops helps with livestock cropland integration. So those are roughly between 20 or 25%. Those top 3 benefits is kind of close. So another thing we look at is, when the producers used cover crop for more years, are they able to perceive more benefits than a producer used it for less years? So here we described into 3 categories. One is the non-adopters, less than 3 years, and 6 years or more. So those bars shows the level of agreement. So these 3 here indicates agreement, and above 3 means strongly agree, and below 3 means kind of neutral or disagree. So here we can see that if we look at this green bar here, of those who use cover crop for 6 years and more, so we can see that this dark green bar actually exceeds this light green bar and exceeds this pink or orange bar here. So which shows that when producers use the cover crop for more years, they are more likely to perceive the benefits. So we can see that for the first 2 categories, improve soil health, increase water infiltration. So it clearly exceeds 3 by the first 2 categories, which means even those who use less than 3 years who also perceive a improved soil health and increased water infiltration. But for the rest of 4 categories, for the crop livestock integration, the weed suppression, and reduce the fertilizer inputs, and the increased cash crop yield, we can see that only those, most likely only those who use 6 years or more, they agree with those benefits. But those who use less than 3 years, only they perceive agree with weed suppression, but for the other categories, they are not likely to agree with. So that, which means when the producers use cover crop for 6 years or more, they are more likely to see more benefits and agree with more benefits with using cover crops. So that, which means that the usage years also play a role in recognizing the benefits of cover crops on their fields. So here is another benefits, I think perceived by most, like slightly more than 40% of producers, in that we ask them if there is a extreme weather events, either drought or floods, whether you are about to use cover crops to protect those fields affected by those extreme weather events. So more than 40% of producers indicated that they are likely to use cover crops. So those are among the producers who maybe not using cover crops right now, but at least that shows that a producer have recognized that cover crop could be used as a method to adapt to the extreme weather events. So that's another benefit of cover crops that we found that producers have recognized. And the top 3 challenges perceived by South Dakota producers. So here we also only list those producers who strongly agree with those challenges. So producers who agree or neutral, we didn't list them here. So all those percentages are strongly agree. So here we can see that nearly 30% of producers strongly agree that high seed cost is a top challenge for their cover crop adoption. And then which followed by a 22% producers realize a narrow planting window is a challenge for them. And then 21% listed a lack of time or labor is a challenge for them. So those are the top 3 challenges. So here is a summary that we did for our findings. So what we found first is we found that cover crop adoption rates did slightly increase between 2018 to 2021, which increased from 51% to 57%. And we found that among the cover crop users, actually, most of them have used it for less than 3 years. So it's nearly half of producers have used it for less than 3 years. And about the people who use it on their fields, we found that more than 60% of cover crop adopters actually only use it on less than 20% of their fields. And we found that more than 60% of cover producers users did not receive cost share, but we also find that cost share actually increased the percentage of field covered by cover crops. And although we found that most people use the cover crop for less than 3 years, but meanwhile, we find that when producers use cover crop for more years, they are more likely to perceive an increase in profitability, and they are also more likely to see the other benefits, like the soil benefits, the weed suppression, and the other listed benefits from cover crops. So the top challenge we found among SD producers is the high seed cost. So which shows that the cost concerns is still the top challenge. So those are the summary of our findings. So thank you very much for your attention, and just let me know if you have any questions. Thank you.
All right, thank you so much, Tong. If you want to go ahead and stop sharing your screen, I'm going to pull up that CCA credit.
Okay.
Okay. So we'll leave that pull up for just a minute or two, as well as the CCA credit there. And we'll see if we have any questions coming through. And then while that is up, I will just go ahead and introduce our second speaker of the day. So our second speaker is Ali Nafchi. Ali is currently the assistant professor and SDSU Extension Precision Agricultural Specialist. And today he will be giving a talk titled, Why Precision Cover Cropping System? So we will go ahead and I will stop screen sharing and you can go ahead and begin your talk. And thanks again, Tong.
Thank you.
Good morning, everyone. Do you have my screen?
Yep, your screen looks great.
Okay. I'm going to talk about precision cover cropping system. So the question is, why precision cover cropping system and how precision cover cropping system can help me? So cover crops have potential to improve soil organic matter, water infiltration rate, water holding capacity and environmental quality in combination with minimum or no-till systems. The cover crops will help also to control the pests such as nematodes, suppress weeds, reduce soil compaction, eliminate the need for annual deep tillage, and increase crop yield indirectly. So, however, in current cover cropping systems, a relatively uniform amount of cover crop seed rate or seed mix is planted in a field despite the considerable variation that present in soil texture, soil type, and other major factors within and across production fields. The uniform rate and seed mix over the entire field can be costly, which is challenging and may not maximize the benefit of cover crops. So therefore, precision cover cropping system can further improve the benefits of the conventional cover cropping system and will help growers to make informed decisions. So as you know, variation in a field results tremendous amount of variability in yield. So all crop inputs, fertilizer, irrigation, seeding rate, everything was same for these two locations of a 10-acre field. However, the yield was 4 times more in the area with heavier soil texture or better soil in left side. So as we have variation in soil properties, which cause variation in water holding capacity, infiltration, and soil nutrient availability, precision ag can help to address this variation by applying the right input in right amount, right place, right time, and in the right manner. Considering these 5 R's in precision cover cropping system practice, so we can choose right seed mix selection and at the right seeding rate and in the right seed placement, right time, and in the right method or manner. So primary steps for precision agriculture concepts are first to find to find and identify the variations, to create different zones and treat each zone individually. So management zones philosophy is managing each crop production inputs like fertilizer, tillage, you name them, on a site-specific basis. So by subdividing a production field into a smaller unit called zones and managing each unit separately. So yield and soil data, nutrient requirement, pest infestation data, and other information, weather forecast can be used to perform the zone management concepts. So aerial imagery, soil electrical conductivity, soil sampling, yield maps, and soil survey provided by USDA are the method we can create management zones and create the zones. And the good news is the aerial imagery, electrical conductivity, and yield data have really good correlation if we do them right. And by one of them, we can get idea about our field conditions, and by adding benchmark over years and historical data, later we can refine them to make better and have better judgment about our fields. So variable rate technology would help to optimize our operation, similar to the cover crops as an input or practice we call it as input. In cover crop mix selection or variable seeding rate, variabilities to consider are not only limited to the soil variations. So of course, we have soil properties package, which is, texture, organic matter, moisture, nutrient, you name them. But then we will have diseases and pests, and topography aspects, compaction, hard pan, soil temperature. And here, because I'm not going to talk about the soil, the disease and pest, I talk about the disease and pest, how we should consider this parameter or factor when we are choosing our cover crop. If we have problem with pests, let's say we have nematodes, soybean cyst nematode in our field, we should not have a cover crop which is co-host for that cyst nematode. So now you can see in some area which you have, and now if we go and correlate or relate the cyst nematode population to soil type, so some area of your field which are really welcoming for nematodes, cyst nematode, so you don't want to have cover crop which are co-host and for that nematode. So similarly for diseases, some cover crops are host or co-host for common diseases. We don't want to have those cover crops in our rotation, or some in some area we will have outbreak of disease, so we don't want to plant it there. With that, I'm going to talk about the soil properties and topography, compaction, and temperature. So when we have all of these variations and variabilities, it would cause non-uniform stand. And when we have non-uniform stand, we will have uneven maturity. And when you harvest your field, some area is not matured yet. And especially here in South Dakota with shorter season, we will have problems. So soil temperature, these are some facts or phenomena. Soil with cover crop cooler the soil. And so maybe it's a red flag, because I don't want in my short season to have cooler the soil. I want warmer soil. But we will explain this, how cover crop will help. Higher organic matter, darker soil, so warmer the soil. Higher soil moisture content, cooler the soil. Deeper in soil profile, cooler the soil, but less temperature fluctuations. So when we have cover crop placed in a field, when we, at the time of planting, we disturb the soil, we will have bare soil. So we consider that area or the stripe is not having cover crops. Therefore, we consider that area attracting more or obtaining more sun. So it would be warmer place for just the band of the seed. So it would not, you will not have cooler the soil at the place you want warmer the soil when you are planting. So we fly over with drone, or now we are working on satellite observation to read the thermal imagery or create thermal maps. And based on the thermal maps or thermal imagery, we will know which area we will have cooler the soil. And later we want to, why do we want to know about this information or thermal imagery? Because we want to compensate the cooler soil with different seeding rate or selections, if you will, to make the field more uniform. Topography and aspects. So when we have north-facing slope compared to south-facing slopes here in Northern Hemisphere, it's obvious we will have sun in north-facing slope, which all the snow melted in south-based slope. So these are the phenomena we never consider when we are planting cover crops. So with precision cover cropping system, we think and we believe we should change our maybe seeding rate or seed selection for different scenario here. And so the top graph here is the bare soil, soil surface temperature, bare soil, and the lower graph is soil surface temperature with cover crop. So as I mentioned, when we have cover crop, the maximum temperature, soil temperature happen to be sandy soil, which is obvious. For cover crop was lower for field with cover crop. Again, this is for covered crop. Now, when we go and plant, we have a band of disturbing soil. On that area, you will get 55. So you will get combination of benefit of both. So you will have bare soil at the band you are planting, and you will have lower temperature rest of your field. So you will have less evaporation, and you will hold more water for your plant growth. Another graph here I have is at the depth of 4 inch, the bare soil has the similar thing in cover crop system. We will have lower temperature. But the point is fluctuation is less. So in sandy soil, we will have the maximum 43. So imagine if we have that band of cover crop, we will get that temperature. Rest of the field with cover crop, excuse me, we will get 30 degrees, which we can manage to have zero evaporation. Variable seeding rate and seed mix selection can help to compensate the soil temperature variation, and different seed mix selection can help to address the field variation because of the, let's say we have problems. I'll get to the soil compaction a little bit. And finally, in different seed mix selection, we can manage the pest. The example was system auto, for example. And I sent you a few links. You can go and see which cover crops are host for system auto. And based on that, we will have different cover crops which are co-hosts for different diseases. So we should not put them in rotation. So the mix selection would be different. So now managing soil compaction. Soil compaction is a big issue, and nationwide farmers across the US lose over $1.2 billion in crop revenues every year just due to soil compaction. And managing soil compaction is very important. But the question is how to identify compaction problems. And so these are very straightforward: reduce water infiltration, uneven stand, shallow roots, and penetrometer. And this is what we see in a field with compaction or hard layer and uneven stand, shallow roots. Sometimes the reducing water infiltration rate would cause denitrification. We don't want to talk about that. And cone penetrometer. Cone penetrometer is a device to measure or quantify the compaction. And if you don't have this device, all you need to do is, have a half-inch rod pointed like a cone at the tip of the rod, pointed to be just like a cone, and you weld another piece on top of that like a T. So now imagine with 200 pounds of weight, you should be able to push this one into soil. And if you are not able to do that, it means you are reading more than 300 psi, which that is, critical number. We'll get to that point. If compaction exists, then deep tillage is needed, or we should do something about it. So if we are practicing, if we have tillage system, deep tillage is needed to rupture the compactor layer for optimum crop performance. But if we don't use tillage, cover crop can do this for us. So this is what I was talking about, the compaction level. If you are below 300 psi, so we don't need to have any tillage or do any tillage. But if we are above that here, so we need to rupture this area. And now, of course, when you have tillage, you will rupture it easily. But with deep-rooted cover crop system, you can eliminate the need of tillage and then reduce the soil compaction. In this graph, the green curve is related to cover crop. And another recommendation is when you are below 300 psi up to depth of 15 inches, the recommendation actually is up to 14 inches. When you maintain the PSI below 300 up to 14 inches depth, you don't need to have any tillage, even after that 14 inches if you have higher PSI. So you are going to maintain the below 300 PSI up to the depth of the 14 inches. So here, we maintain that 300 PSI up to 15 inches depth. If we didn't have cover crop, so we at the 8 inches, we have 400 PSI here. And we have to break this area. And if we don't break it, it would cause yield reduction. With cover cropping system, with deep-rooted cover crop system like tillage radish, and now when we are talking about the deep-rooted cover cropping system, we may think, okay, yeah, tillage radish, what else? Cereal rye. Sometimes the cereal rye roots goes up to 6-7 foot. So that is very deep. Of course, we have tiny roots. Still, we are improving the void ratio and porosity of the soil, which will help with the, in long term, we will have higher organic matter and higher infiltration rate and higher water holding capacity. Another point I want to mention here, soil moisture content. When you have cover crops, especially the time you have lots of dew in the morning, that would absorb lots of water just from the source of dew, and it would return it back to the soil. And that is also a factor we can consider. Yes, in short term, we don't see all of that because we don't establish that microorganisms and the soil cycle with the cover crop, because we are adding something new to the soil. We may not able to see the result as Tong mentioned, but in long term, yes, we can see the benefit. So back to precision cover cropping system, when we have all of these variations, we need to make a logical model to apply different seed mix and different seeding rate based on the needs. And so we can improve our practice by doing that. I sent you 3 links which you can go ahead and look at them. One talks about the cover crop for soil compaction. Another is which one of the cover crops or host or co-host for cyst nematode, and what other options we have to prevent erosion. So with these topics, so we talk about the precision cover cropping system. We have two ongoing projects. We have precision cover cropping system for enhancing soil health and increasing farm profits, funded by USDA and RCS. And also we have using the wide drop system combined with a cover crop planter to improve nitrogen use efficiency to interseed cover crop at the time of side dress. This project funded by South Dakota Nutrient Research and Education Council. If we refer to Tong's presentation, we had challenging of time in short period here in South Dakota. We don't have time really to when we harvest. Usually when we harvest the plant, there is no time to go and establish good cover crop. So we want to interseed the cover crop for existing plant. Now we are thinking about corn and later soybean. We don't want to create competition between cover crop system and the main crop or cash crop. For that reason, we want to wait till the time there absolutely no competition can be between the main crop and the cover crops. For that reason, we wait till V6 to V8, and we plant the cover crop at side dress. Another idea was to coat the seeds and extend the dormancy or make them dormant and delay the germination for at least 2 months or so. The time, so we got to the level of the maturity of the corn or maybe soybean, and that's the time. So we have enough light at the time the cover crop would take off, and it will use the time between September 15 to the winter. That time which we cannot do anything, so we have our cover crop established. So that is wide drop and precision cover crop system, which I explained. We want to have a logical model to if we don't need some cover crop in some area, we don't want to plant it. If we need different rate, and different rate would help to improve or get more benefit of the cover crop, we will do so. And on our program, which is on-farm research and extension program, we will work with farmers interested in participating and trying new and innovative technologies. And we will work with them to establish on-farm research and outreach activities, prototype fields to establish these two type of research and to show the benefits of cover crop, precision cover cropping system. Here are my contact information. I am going to talk about precision agriculture concepts on March 3rd. I will explain more about how we go and use the data. There was no time to talk about how we use electrical conductivity or aerial imagery. We will talk about them. We will have more time there to explain those topics. So thank you very much. And I'll take your question.
All right, and if you'll stop sharing your screen, I'll go ahead and throw up that CCA credit. All right, and if anyone has any questions, now would be the time. And I did post a link earlier in the chat. We do have one more Winter Agronomy Roadshow event in Sturgis. It'll be February 17th. So we hope to see everyone there. All right, and if there are no questions, we hope to see you next week. And thank you both so much for speaking today.
Thank you.
Thank you.